Good morning. Actually, I guess it's good afternoon for some of you. I have a sick kiddo, so I am going to walk you through today's 11.1a and 11.1b via video, and hopefully it will make perfect sense. It's pretty straightforward. Just a couple things as we start a new chapter. There's a formula sheet again, just like there was for chapter 10. And it's set up the same way in modules. So if you click on the chapter 11 module, you'll see your notes are there, you'll see your book pages are there, and then there's a blank version of the formula sheet and a filled in version of the formula sheet. So you may use whichever one you want. You won't need it today yet, but if you want to take a look at it, that's fine. So take a minute right now to get to that new module because you probably don't have the notes pulled up yet. Since we're just starting, go ahead and pull up those notes and we will get going on the lesson. All right, so chapter 11 is all about area and volume, but with three-dimensional figures now. Volume, right? But that means lateral area and surface area are the types of area that we're going to be talking about. So the formulas are different than what we did in chapter 10, but some of that will come into play in chapter 11. So we're going to start with 11.1a here, which is space figures is what we're calling it. First thing you need to know is what is a polyhedron, because we're going to deal a lot with polyhedrons in this chapter. So it is a space figure. When we talk about a figure in space, we're talking three-dimensionally, whose surfaces are all polygons. And if you think back to first semester, we said a polygon is a closed figure. It's going to have straight edges, so like a circle is not a polygon. But it's going to have faces that are all polygons, so like a rectangle, a triangle, a pentagon, those types of things. When you look at a polyhedron, there are some different terms that are going to come into play for us. So the first one that we'll talk about is what's called a face of the polyhedron. When I say its surfaces, its faces. Okay, so for instance, this rectangle right here, we call that a face. Okay, so that is the face, the front face, if you will, of that polyhedron. There are also what are called edges, and that is a segment on one of the polyhedrons. So this is called an edge. Sorry for the goofy little thing there. That's nothing. And then the last thing that we're going to talk about on this figure is called a vertex, and that's where three or more of the lines come together. We've talked a lot about vertices in the past. We'll go singular here. Vertex, okay? So vertex, edge, and face are the three things we're going to focus on for a little chunk of this lesson. So if you look at example 1, it says how many vertices, edges, and faces does this figure have? So our vertices, if you look, you can kind of highlight as you go if that's helpful to you. These points are where three or more lines are coming together. So we have 4 vertices in that. Our edges, I'll go back to the red, would be all the segments that connect to those vertices. So 1, 2, 3. This one in back is dotted because it's not visible to the naked eye. It would be in the back of the figure. So that would be 4, 5, and 6. So 6 edges. And then how many faces do you have? You can highlight these as you go if that's helpful to you, but there's going to be a little bit of overlap there. Basically, you have the back face, kind of the front left face, the front right face, and then that bottom face. So there would be 4 faces here, 4 polygons, if you will. All those polygons in this figure are triangles. They won't always be that way, but in this case they are. So there was a man, his name was Leonard Euler. I know it doesn't look like Euler, but you say Euler, who was a Swiss mathematician, and he found that there is actually a relationship between these 3 things in any polyhedron. What he found was if it is a 3-dimensional figure versus a 2-dimensional figure. Remember, 2D figure is just called a net. Remember, we talked about nets back in chapter 1. So if it is a 3-dimensional figure, Euler's formula is faces plus vertices will always equal edges plus 2. Okay? So example 2 here says how many faces, edges, and vertices are in the figure, and then use that information to verify it with Euler's formula. So Euler's formula is going to be a way for us to check things. Sometimes we'll use it to find missing parts, but on this one we're just going to use it to do a check. Okay, so I'll try and use the same colors so I'm not mixing people up. So vertices and edges and faces. Okay, so let's start with vertices here. There's 1, 2, 3, 4, and 5. Edges, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then faces, there is the face in back. There's the left side, or sorry, that would be the right side, the left side. So there's 3 up there. And then on the bottom, there's the 1 in back, and then the left side, and then the right side. So 6 of those. Notice I didn't count the 1 right here because that would be inside the figure. We just want what is on the outside of our figure. Okay. So if we use Euler's formula, it says faces plus vertices equals edges plus 2. So faces was 6, vertices was 5, edges was 9, plus 2. Well, 11 equals 11, okay? So that checks out, and that's what we're looking to do, make sure it checks out. His 2-dimensional version is very similar. We don't use this one quite as much, but it's faces plus vertices equals edges plus 1. So if you take your figure, think about what figure would this be 3-dimensionally? It'd be a cube, right? You don't need to draw a cube. I'm just showing you what it would look like if it was 3-dimensional. So if we take that and we lay it out as a net, how many faces, edges, and vertices are in that figure when it's a net? And then we'll check it against this one. So take a little bit right now and try that for me. How many vertices do you count? How many edges do you count? How many faces do you count? And then I will do it with you in just a minute. All right, let's take a look. So your vertices, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so there's 14 vertices. Edges are all the segments that connect those, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, and then the faces are each polygon. So 1, 2, 3, 4, 5, and 6. Okay, so that's what hopefully you got. Then we check it against his two-dimensional formula since we were using a net. So faces plus vertices should equal edges plus 1. Okay, so when we plug this in, faces is 6, vertices is 14, edges is 19, plus 1. So we get 20 equals 20. Okay, so that checks out, and that's what we're looking to do. Okay, I'm going to go ahead and have you guys pause the video right now, and I'm just going to have you take some time to try this, and then we'll come back and I will teach you the second one in a little while once everybody is well on their way on this one. You are going to have a lot of time in class today. So you should absolutely be able to get your homework done so that you don't have homework post-Broadway. For those of you that are in Broadway, it should go fairly quickly. So please take advantage of the time that I'm giving you for today. I was trying to give you plenty of time to get it done in class. So go ahead and pause for now, and then we'll pick up on 11.1b in a few minutes. Okay, guys, this lesson is really short also. Like I said, trying to give you plenty of time to get all the stuff done with Broadway going on. So we are going to talk for the second half of this lesson about cross sections. And a cross section is just the intersection of some solid and a plane. Okay, we talked about planes back in chapter 1 again, so we're really drawn back from our chapter 1 knowledge here. When we take a plane and we intersect it with some solid, we're basically looking for, treat that plane like a big knife that's going to cut through the solid. What would be the overlap of the two things? So if you look at this figure here, that kind of blue figure, we call that a triangular prism. And then we have this yellow plane that cuts through our triangular prism. The question is, what is the cross section? What is the intersection of those two things? What's the overlap? Okay. So when that plane cuts through, what happens is this would be touching both of those things, the plane and the solid. So your cross section is that purple triangle. Okay. Look at the figure on the right there. If I cut a plane right through kind of the middle horizontally of, this would be called a square pyramid. If I cut through that square pyramid, what happens is when I cut through, I get this smaller square, right? It's further up the figure. So it's going to be smaller than the actual base of the figure, but still the shape of a square. So it's still going to be the same shape as the base. Maybe tell your neighbor right now what you think the cross section would be if I went through this figure vertically. So if I cut through the same way this one cut through, what shape do you think you would get on that figure? Tell your neighbor. Did you all say triangle? That would be a triangle if we went through vertically. Remind me on Monday, because that's the next time I'll see you, to pull out. I have a bunch of 3D figures that I usually pull out for this lesson that I can actually show you with, but today I will not be able to. So remind me Monday to show you those, because it gives you a good visual, a good idea of what's going on here, okay? Okay, so you're going to be doing some naming of cross sections with this stuff, both directions. So if I go vertically through, basically I'm saying if I draw a plane vertically through this figure, okay, what shape would you see? So if you think about taking a soup can, that's solid soup can, okay, full of, well, I wouldn't say full of soup because as soon as you cut through it, it's just going to come out, but full of material of some sort. The shape you would see there would be this. Okay. So that would be, if you go vertically through, you would get a rectangle. Okay. I'm just going to redraw a new cylinder over here. I should have just made a copy, just so you can see both of these. If you were to go horizontally through this, hi, baby. There's my sick kid coming down. I'll be right back. Okay. So if I draw that plane right here, the cross section, the overlap of those two things would be that circle. It looks kind of more like an oval, but that's just perspective here. Think about if I took a soup can and I just sliced horizontally, I sliced a layer of the base off, there would still be a circle bottom. I wish I had my things to show you because it's such a good visual when I can show you my things. All right, letter B here. This is called a cone, right? So here, we're going to write this. This is a cylinder. This is a cone. Okay, so with a cone, what happens is if I go vertically through, again, actually here, I'll make a quick copy so I can just do two separate ones. You might want to do the same thing with your notes if you want to leave them both on there. Vertically through this, okay, if I cut through like this, I would get the triangle. Right, so if I go vertically through a cone, I'll get a triangle for my figure. If I go horizontally through a cone, tell your neighbor, what shape do you think you will get? Yes, it's a circle. Okay, notice it's a smaller circle than the circle that's there, but it's a circle. I could go up here and it would be an even smaller circle because it's getting further up toward the point, but it's always going to be a circle horizontally through that figure. All right, this one, go ahead and make another copy if you want. Okay, if I go vertically through this figure, it depends now where you go vertically through, how big your figure will be, because if I were to go back here vertically through, it would be different than if I were to go right here vertically through. The shape will be the same. It'll just be a different size of that shape. So let's just say we're going to go vertically through right here. Okay, if I cut vertically through that figure, what I get is a rectangle. You have all this, and we shade it in. Okay, so vertically through, we get a rectangle. Okay, if I were to go horizontally through this figure, so cut through something like this, horizontally through will be the same shape as your base. So in this case, that would be a pentagon. Okay, because my base is a pentagon. Basically, we're just cutting off a sliver, and we would get a pentagon overlapping the plane and the solid. Okay. Okay, last thing we're going to do is we're going to draw a few cross sections. So let me just show you. I might make a couple extra copies of this too, just so I can show you a few more since I'm not there to help you when you're doing homework stuff. want to say hello? No? Kenzie's watching your lesson too. Okay, so if I were to do a vertical plane, remember a cross section is just the overlap of a solid and a plane, okay? So if I were to do a vertical plane, pay attention to wording here, vertical, right, up and down. If I were to do a vertical plane that intercepts the right and left faces of the cube. So your right face is over here. Okay, your left face is over here. Notice I went top to bottom on both of those. So I went from top to bottom on the left, from top to bottom on the right. If you draw those lines in and then connect all your vertices, that will be your cross section. So you just draw it in and then shade the figure that you got. So we got a square here. Shade that square in, okay? And then your cross section is the red. Okay, letter B. It says a plane intercepting the top and the front faces of the cube. Now this one doesn't say vertical or horizontal, but if you have to go through the top and the front, oftentimes we're trying to draw parallel lines. I'll show you a situation where we're not, but typically you're trying to draw parallel lines. So the top and the front, if I go like this, okay, that's really hard to make a cross section that's actually going to cut through that. An easier way to make parallel lines through the top and the front would be to go horizontal here and horizontal here. And then if you connect your edges and shade that in, that will be your cross section. Okay, so it's kind of like cutting the front edge, the top front edge off, if you will. And I can show you more of that in class again as well. The last one I'm going to show you is, I think there's one of these in your homework. If I was going to go through the top, the front, and the right face, okay? Now you are not going to be able to do parallel lines through 3 faces. So this is the time that you won't do parallel lines anymore. All the rest of them, you'll try to do parallel lines and connect your endpoints. But if I go through top and front and right, I can make a triangle out of those 3 lines, okay? So that's the goal, make a triangle, and then shade that in. So it's kind of like we just cut the corner off of the figure, and that would be our cross section. So our cross sections here are both rectangles. This one is a square, but it is still a rectangle. This one is not a square, but it is a rectangle. And then this one, your cross section would be a triangle. Okay, so that's 11-1. Like I said, you guys have a lot of time, and I do that so that you can get everything done before your dress rehearsal tonight. So use this time wisely, get the homework done, then you won't have homework to worry about with Broadway. Have a lovely weekend. I can't wait to see those of you that are performing in Broadway on Friday.